video today, I'm going to cover surface plots. So these are 2D representations of three-dimensional plots. And later I'll cover 3D plots. But for now, I just want to cover 2D surface plots. So let's motivate this. So imagine we have a function. So maybe we're going to take a two-dimensional function, x and y. And what we want to return, let's do a Gaussian. So we're going to have x squared, let's do minus x squared plus y squared, and that's also going to be a minus. So this is going to be kind of a two-dimensional Gaussian, and we want to represent that surface, or the curve, this two-dimensional Gaussian curve. Now to represent this, what we're going to have to do is define x and y over kind of the entire plot. And so what we can do is we can say, let's take x is equal to np linspace of -1 to 1. Let's do that. And we're going to do 5 points. And then we're going to do y is np linspace of -1 to 1, and then do 5 points. Now, if I ran f of x comma y, what it's going to do is going to give me back, whoop, I got an error. Lots of typos. Space, and is what it's going to do is going to give me back an array where it's going to do element by element addition of these two arrays. So x is -1 to 1 to 5, and then y is -1, 5. And so it's going to evaluate this for the first element. So this will be the first element of x and the first element of y. We'll square both of them, take the minus sign, and then evaluate the exponential. Likewise for the second, the third, the fourth, and the fifth. Now the challenge with this is that we don't have actually kind of a surface representation. And what we really need is these x and y values defined for all, for kind of an entire surface. And probably the best way to show this is using a function called mesh grid. So we're going to take np x, we're going to take big X and Y, and we're going to do np mesh grid x comma y. And let me print up x, and I'll print a space there, and then we're going to print back y. And these are both going to be matrices. Now, if we look at the x value, and the way I think about it is kind of the graph going up this way, and then the graph going down this way. And so we see the x values. So as we move to the right, we get -1, 0.5, 0, 0.5, and 1. So these are all the x values. But this is the x value at the bottom. This is the x value one up from the bottom, in the middle, above that, and above that. Likewise, we have our y values. And our y values are going to start at -1. So actually, the origin is kind of upside down here. But we're going to start with -1, -0.5, 0, 0.5, and 1. So these represent the y values. So if I take this point, right, this refers to the point where x is equal to -0.5 and y is equal to 0.5. Whereas this point right here is where x is equal to -0.5 and y is equal to 0. And the nice thing about this is it kind of fills out all the x and y values, because basically we need an x, y value for everywhere in the plot. So if we're going to do a plot of some surface in the space, I need the x, y value here, 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 kind of going on and on. And what's nice about arrays is arrays function just like matrices function just like arrays. It'll be element by element. So if I did f of x comma y, what I'm going to get back is kind of an array where here's the center position. So this is when x and y are 0. This is the position where x and y are -1 and -1. Here's the position where they're 1 and 1. You notice it's kind of a symmetry here, because a minus becomes, well, because we're squaring it, gets rid of the minus sign. And we basically have the different values for that. Now, if we want to get it clear, we're going to put more points in. So maybe we'll do 50 points here, right? And then we're going to have kind of a mesh grid. And then what we can do is, if we want to look at a surface, one of the ones we could do is do p color. We could do x, y, and f of x comma y, and then PLT show. And what we're going to get back here is kind of a heat map, right, of kind of our surface, right? And if we want to look at the basically the intensity, right, at the center of a Gaussian, right, we're going to be close to the value 1. And then as we move away, we're going to drop off. Maybe we want to make this a little bit clearer. Extend the domain from -2 to -2. And we kind of have that circle there, which represents kind of a looking like top down. It's almost like a relief map of the Gaussian. We can also do things like PLT axis. We can make it equal, right, since we have equal axis. And then maybe PLT axis square. Whoop. Misspelled square there. And so we have kind of the axis square. And now we have our two-dimensional representation of the Gaussian. The other way we could do this is we could also do a contour plot. So we could do contour, we could do x, y, f of x comma y, and then PLT show. And this second one's going to give us kind of the contour levels of our plot. And again, we can do, PLT. Let's just grab all this. And we can run kind of the contours of it. We could even put a color bar here, right, to show the contour levels. Right, and then we're going to have the levels of 1.5, 0.9, 0.75, 0.6, down to 3, down to 0. And this is just another representation of our kind of Gaussian curve, right? And here we have just kind of a contour plot. It's possible to go in and change the contour levels. Let me just cheat really quick. I have an example over here from the sample. And let me just grab this bit of code. I never remember this off the top of my head, so I'll come back here. And what we can do is define levels, and maybe we want to specify them in 0.1 or 0.01, 0.1, 0.5, and 0.9. We run it again, and now we're kind of specifying our contour levels here. All right. It's actually getting a little bit complicated. Maybe we'll take out that 0.01, and we have kind of our contour levels here. Maybe I'll put in like a 0.75 here, and maybe a 0.25. There's another kind of level. And we kind of have our levels in our contour plot. We could also change the dimension of it. Maybe we can make this kind of skewed. Maybe we could do 3 times there. And now we're going to have kind of a skewed Gaussian, right? So it's kind of more oval shape than circle shape. But again, we see the kind of the contours of our 3-dimensional plot. So again, coming up here, this function x and y is a surface in 3 dimensions, right? Because it's for every value of x and y, we get a z value, which is what this function is returning, right? And then we define kind of our domain x and y, but we have to create an array, which is the big X and big Y, that kind of give each x and y value in this kind of surface plot. So that's what the big X and big Y are doing. So like if we come over this point, it's telling us, hey, y is minus 0.5 and x is minus 1, and so on. So we have to define each one of these points kind of in this plot, and that's what MeshGrid does. It does it kind of, fairly nice. It kind of regenerates it for you. We could also change the dimension, right? We could also go, in another one, we could go 3 to 3, right? And now, right, so y is 3 to 3, but x is minus 2. Why is it going to 4? Oh yeah, because I did the axis equal. That's why. So if I take these 2 parts out, you have the plot, and now we have going from x from minus 2 to 2, and y going from 3 to minus 3. In general, I tend to like making things square and kind of square axes, because it's a little bit easier to see and then kind of determine the different values for it. So this is kind of one overview of kind of 3-dimensional plots using kind of peak color and contour. And they're both kind of nice. And then later, they're actually easier to visualize kind of surfaces in 3D, just because there's less variables to kind of tweak in these problems. As you'll see when we get the 3-dimensional plot, there's lots of different variables, how do we want to represent the surface in 3 dimensions? We can rotate it. We can define where the the light is kind of reflecting off the surface. So one last thing we can do with P-Color is we can change basically the coloring scheme, and there's all different kinds of coloring schemes. And so basically we have an option, CMAP, and maybe let's try Jet. And with Jet, I get just a different coloring scheme. So this is kind of the Jet coloring scheme. And if you want to look at kind of the documentation, there's hundreds of different coloring schemes. You can define them yourself. Typically, Jet's the one I like using. It's still a little bit not perfect here, so maybe we can add a couple more points, kind of smooth it up. Maybe 100 and 100. And now we kind of get a little, at least smoother representation in 2 dimensions. I'll give you guys more examples later of surface plots, but I want to just kind of toss this one out here with a quick video. I also posted some examples on Compass, a little bit more complicated, a little bit more cleaned up for you. If you have questions, again, just post them in the comment section or put them on Piazza. Hopefully this is clear, but this is just kind of more functionality with plotting. Here using just 2 functions, P-Color and kind of contour to help you along. All right, thank you.